Good morning, students. In today's class, we are going to discuss the problem, that is the three-phase fault current when fault occurs at the middle of the line, which is shown in the figure, which is the diagram is represented by using the single line diagram. So this problem I am going to explain you detailedly. So here we have two generators, generator 1, generator 2, that is neutrally grounded, both the generators, and here two transformers are given, T1, T2. One transformer is star connected, both the side, primary secondary, and other transformer is star connected and neutral grounded at one side and delta connected on the other side, and in between the fault is acquired. Okay, so here for the solution is we have to write the base value, that is power value and voltage value given in the question. Then we have to find out the reactance for generator by using the per unit formula. Okay, then the reactance of transformer also T1 also calculated by using the per unit formula. Then reactance of transmission line is also calculated with the help of per unit, that is the actual reactance is given and the calculated T1 value is also given in the question. So together we multiply it, we'll get the reactance of the transmission line. Then reactance for the high transformer side, transformer 1 also, the formula is given. We have to solve it, and this is the value. So base impedance value formula is given. The per unit reactance is actual impedance by base impedance. So transmission line impedance value is given in the question. Then base impedance value already we have calculated. So on dividing these two values, we will get this answer. Next, reactance for transformer 2 also, all the values are given in the question, base value. Then by using the formula, we are going to calculate the reactance of transformer 2 in terms of per unit. Okay, so then the transformer on a low turn side of transformer T2 also, the formula is given. So this is the new value. Then we have to substitute in per unit equations and find out the value for reactance of generator 2. So after finding out, draw the reactance equivalent reactance diagram for each equipment. This is the fault current IF. Fault current IF. This is ETH generator value. This is the XF value. XF value. This one is fault is acquired at the middle line. Okay, so the fault current is given like this. So the above diagram can be reduced and it is simplified. The resultant value is given in this diagram. So next one is equivalent circuit diagram, Thevenin's equivalent circuit diagram. Here the reactance value, it is mentioned, that is after reducing this. So here fault acquired, so this reactance value series, this one is series. So the resultant diagram will be like this. The resultant diagram will be like this. So the next one is final diagram will be like this. Here reactance ETH value is given. So next one is XTH, that is by connecting in parallel the value resultant value and the pre-fault voltage, fault reactance impedance value. So altogether is given like this. So fault current, calculating the fault current value. This one is the fault current formula. So after calculating this, we are getting the IF value here. Base current value formula is given. So the total fault current is base current into fault current formula. So next problem number 3 also, the question is given. Here two generator G1 and G2. That is two generators G1 and G2 is given. G1 motor, transmission line, reactance value, everything is given in the question. Then reactance for generator 1, transmission line reactance, motor M. So all the values are given and per unit values are calculated in the formula. The resultant diagram is given like this. The resultant diagram is given. Then the resultant Thevenin's equivalent circuit is drawn like this. ZTH voltage value is given. So pre-fault current Thevenin voltage formula. For subtransient reactance, the formula is like this. This one is the formula. Base current, actual fault current, both multiply together, we will get the fault current formula. Then for subtransient fault current generated by generator and motor also, the formula is Ig is equal to Jxm divided by Xg plus X plus Xm. So this is the Xg value, this is the Xm value. Here altogether we are going to substitute the total X value. Then fault current is given. Then after substituting, we'll find the Ig and Im. Okay. So this is subtransient fault reactance formula. This is subtransient fault current contributed by generator and motor. This one is problem number 4. Okay, so this one is here fault is occurred at the end of the transmission line T2. So here also the reactance of generator G1 also calculated by using the formula G2 T1 and T2 value. Then reactance of transmission line, everything is calculated. Equivalent per unit reactance diagram is drawn. This is the Thevenin's equivalent circuit. And here also by using the reduction technique, we are calculating the equivalent impedance value. Then ETH value we are substituting. The fault reactance impedance XF should be equal to 0. By substituting these values in the formula, we'll get the final current, actual value of fault current in the formula like this. So fault current supplied by generator, that is generator 1, generator 2 separately. Actual current we have to find out. Then we have to find out the base current. Then we have to multiply the fault current in per unit into base current will give the actual value of fault current. Okay, this is for generator 1 and generator 2. Thank you, students.